Hello, and welcome to this T-Level Tactics video on data maintenance for Root Core 3 data of the T-Level Digital Support Services course. And in this video, we'll identify the operations of data maintenance, we'll explain who may want to change data and how, and we'll also analyse the resources required to manage expanding datasets. Now, before we get started, these videos are not endorsed or sponsored by any education institution or qualification awarding body. And T-Level Tactics videos should not be used as a replacement to any classroom learning you might be receiving, as the discussion and practical activities with peers and your lecturer will help to expand your thinking and comprehension of the topic. Instead, these materials are best used as preparation material or as revision to reinforce your learning. And these videos cover the same content and required knowledge for Root Core 3 of the T-Level Digital Business Services course. However, they will be more contextualized towards IT support roles. Let's get started and take a look at data maintenance. We know that databases can hold and store millions of records, and that databases can be getting larger every second if they're kept up to date regularly. But databases need maintaining to continue operating correctly and efficiently. Data maintenance is a set of processes and activities involved in managing and ensuring the quality, integrity, and accessibility of data throughout its life cycle. And this includes a variety of tasks aimed at keeping data accurate, up-to-date, and secure. Data maintenance involves cleaning, updating, backup, archiving, security, compliance, and monitoring. Data cleaning is identifying and correcting errors, inconsistencies, and accuracies, and it aims to improve the quality of the dataset. High-quality data provides more accurate results, after all. And it includes error detection, so checking for duplicate entries, missing values, formatting inconsistencies, and outliers within the data. Data correction, such as removing or merging duplicate data and filling in missing values where we can. And validation, where we can validate existing data with reliable sources to meet the set criteria. Updating data is regularly refreshing and modifying existing data, ensuring the data is still accurate, relevant, and useful. And new data could come from users, external sources, or other automated processes. Updating our data maintains the data quality, preventing data decay, which is where data can become irrelevant. And it keeps the data accurate and high quality. Backup is creating copies of data to protect against loss, corruption, or disasters, and safeguards against data loss due to system failures, human errors, and malicious attacks. Backing up data enables organizations to quickly restore data efficiently after a catastrophic event, minimizing downtime and any operational disruption. Organizations need to determine how frequently their backups are created, where they're stored, and how regularly they should be tested. Archiving data is moving inactive or less frequently accessed data to separate storage. And this can optimize performance, reduce costs, and ensure compliance with data retention policies. This could be historical data that's no longer actively used but could be called upon in the future. Regulatory data that must be held to be in compliance with laws and legislation. Or project data for completed projects that is just held for reference or audit. Archiving is often completed automatically based on conditions such as age or last time accessed, and is often managed by software. And it could be implementing access control measures to restrict access based on role or permissions in the organization, enabling data encryption, using data masking, which means you can obscure specific details while showing other data to users, monitoring data access and usage and by who, and auditing existing permissions, and user access privileges. Compliance is auditing processes and systems to ensure adherence to laws and legislations where the organization is operating. And this could involve compliance activities such as reporting, incident logs, and other things. Creating or updating a data inventory, where data is collected and how it is stored and used. Updating policies and procedures in the organization. Auditing staff roles, responsibilities, and access rights. And potentially creating risk assessments and response plans, such as, in case of a data breach, what would you do? Monitoring involves the continuous observation and tracking of data systems, and looking out for performance issues, usage, and other problems that might occur. And it can help to ensure data systems do not experience bottlenecks, slowdowns, or failures. We can also detect unauthorized usage or security breaches in real time. And this monitoring could be real time. It could be in the form of reports at regular intervals, or even historical monitoring over a longer period of time. Effective data maintenance is crucial for organizations to make informed decisions, comply with regulations, and maintain operational efficiency. And regular, effective maintenance helps to maintain data quality and accuracy, increase productivity, and to prevent data loss. So, for our Patreon members, you can download the task sheet from patreon.com/tleveltactics. And if you're not a member, head over to patreon.com/tleveltactics to take a look at all the exclusive content that our members get. Download the task sheet and complete the first task. It will take about 30 minutes. So pause the video here, have a go at the first task, and then come back when you're ready to move on to part 2. Let's take a look at who will want to access and change data in organizations. Databases can be accessed by a variety of people. In large organizations, hundreds of people could be accessing the same database at the same time, and all of them could be making changes simultaneously. But this isn't without a level of control. Users who access databases can be assigned specific roles. There could be users who can only view the data, who could add and update specific fields within records, or they could be system administrators who can make much larger changes. Regular users may be granted read-only access to the database, or they might be able to add specific information that doesn't change or affect the base data. This will allow the user to access data, run queries, and generate reports based on that data, but won't allow them to add, remove, or update data. And this can maintain data quality and accuracy by preventing inadvertent errors and mistakes. Elevated users may have specific permissions within the database. They still have all the permissions of regular users, but they might be granted permissions for specific things. They might be able to create or update data in the database, but might be unable to delete data. Or they might have a specific screen or form that presents data for editing to ensure they're only editing what they're allowed to. Or if someone's performing data maintenance tasks, they might be able to flag data for checking and removal by someone with the correct permissions instead. System administrators are usually a senior staff member who will have full access, read, write, and remove. And they can grant other users additional permissions or even remove them from them. Administrators will be users who can make changes to the core operations of the database and the data contained within. And there could be administrators for different parts of the database, or for the whole database. As administrator logins are so powerful, staff are advised to use a regular user account and only use their administrator login when necessary. All access to data and the database can be logged in software, and this can track what user has accessed data, when, and any changes that they've made. If issues arise in the database, these changes can then be tracked. And access logs are a part of compliance to help monitor and report data breaches. So for Patreon members, you can head back to the task sheet now and have a go at task 2. Now, this hasn't been a huge part of the video, and it's going to be a slightly shorter task. It will only take about 20 minutes. So pause the video here, and then come back when you're ready to move on to part 3. Let's take a look at some different resources. All maintenance requires time, money, and people. But databases don't just need continual maintenance. As they expand, they're going to need continual upgrades, both in software and hardware. We're going to take a look at 3 areas: operational resources, financial resources, and technological resources. Operational resources include time management. How long does data take to be entered? How long do data maintenance tasks take? Is there any downtime? Does the speed of data entry affect its accuracy and quality? Staffing is a part of operational resources. How many staff are required for data entry? And are there separate staff that deal with data maintenance? What training do these staff require? And how much work do staff have? As burnout and too much work can lead to inaccurate data entry results. Financial resources include budget. What kind of budget and finances have been allocated to the database? Does this affect the number of staff we can have working with it? And does it affect the hardware platform the database runs on? How will this budget impact training? We could also look at forecasting as well, such as what future costs are there for this database and how expensive will it be to run? How will the costs for staff change? What impacts do electricity prices have on running the database? And if the database is on site, what about other costs like air conditioning to keep hardware cool enough to run? Technological resources include things like storage. How quickly is the database growing? How much storage is required? What backup and security solutions are required? Is it more effective to have an on-site solution or to move all of our data to the cloud to make things cheaper and potentially more secure? We can look at hardware. Is the database running on a server, and how many staff will access that data simultaneously? Is the server our database is running on capable of supporting all of these users? And how much data are we analysing or running queries on? How long are those queries going to take on current hardware? And when do we expect this equipment will need to be replaced or upgraded? The rate of change of technology is very, very fast, very, very quick. So when we buy new equipment, we need to make sure it's going to last a long time, as it's probably going to be quite expensive. And in terms of software, what software are we going to use for this database? Is it proprietary that we need to pay for, or is it going to be open source? What interfaces are available to use, and are they intuitive for staff to input the data they need to? Can staff easily run queries themselves with this software, and what kind of training is provided for the software? It's also important to think of how long there's going to be product support and updates for. Efficient database operation relies upon a balance of all of these factors. And without correct planning and maintenance, the database may become slow over time, have data inaccuracies, or just may simply stop working at all. As time goes on, you may also find there may be some compatibility issues if you're using that data in other systems as well. So that brings us to task 3, all about these resources. So if you're a Patreon member, head back to the task sheet for this final task. Have a go, spend about 30 to 45 minutes on it. Pause the video here, have a go at task 3, and then come back when you're ready to finish things off with a couple of exam questions. So, in this video, we've identified the operations of data maintenance. We've explained who may want to change data and how. We've also analysed the resources required to manage expanding datasets. Let's have a go at some exam questions. Here's the first one. Identify and explain 3 elements of data maintenance. And for the second, explain the need for data security in data maintenance and operation. So, that brings us to the end of the video. In the next video, we'll be looking at different database structures. So make sure you head over to youtube.com/@tleveltactics. Make sure you're subscribed to the channel and check out all of our other content. And if you haven't yet, also head to patreon.com/tleveltactics to take a look at all the exclusive content that our T-Level tacticians get access to as members, and also access to things like our exclusive Spotify podcast editions. Thanks for watching, and see you next time.